My name is Tin Yun, and I'm a product manager on the Cloud AI team. And today, I'm here to talk about how you can tackle some of your high-value business problems using AutoML on one of the most common types of data in the enterprise, structured data. But before we dig in, I wanted to first make sure everyone knows what I'm talking about when I say machine learning on structured data, right? So these use cases typically start with a table of input, kind of like this, where each row is an independent training example. And usually, one of these columns is the target column, and the remaining columns are input features. And the goal is to create a machine learning model to predict the value of the target column accurately using the available input feature values for that row. So for example, here you may have this is a toy example. You might have a table of historic offers from an online marketplace, and you want to create a model that takes the available data on that offer to predict the price at which that offer is sold. So for example, if you want to provide pricing guidance to your sellers. And one common misconception I wanted to point out is that people sometimes think that you can only have simple values like numbers and classes inside a table. But actually, especially with modern data warehouse systems like BigQuery, you can put a rich set of things in there. Things like timestamps, long pieces of text, lists of features, potentially repeated nested fields, and that would be only getting started. So according to the McKinsey Global Institute, data in this basic form, structured data, is likely to drive most of AI's impact, with time series being a close second. And this really comes as no surprise, because virtually every industry has mission-critical use cases that can be boiled down into this tabular form. So for example, in retail, predicting the likelihood of stockouts, or predicting price elasticity so you can optimize your product inventory. In finance, predicting the risk of large claims or defaults, or predicting the likelihood of fraud in this transaction in order to manage your risk. In marketing, predicting lifetime value, like how much they'll spend on your site in the next 3 weeks, predicting whether they'll churn, so that you can better understand your customer. The list goes on. And these are use cases that are so core to their respective industries that even small improvements in model quality can have significant business implications. But the challenge is that especially as the number and complexity of your input columns increases, you hit a combinatorial explosion in things you need to worry about. So starting from the left and going to the right, on data preparation, for every one of your individual feature columns, you need to think about things like missing values and outliers and so forth. And then under feature engineering, for each of those columns, you need to think of the right pre-processing to prepare it for the following model that you select in the architecture selection step. And there could be multiple options per feature column. And then under architecture selection, there are dozens of models you could choose from, including more that come out from the research community basically on a monthly basis. And then for each of those models you select, you have to select the right hyperparameters, and there could potentially be a dozen values to set. And then you have to think about tuning, think about ensembling if you're trying to create an especially good model, as well as model evaluation. And oh, by the way, if you screw up in any one of these individual steps, frequently you have to start over. And this process of iteration can go on for tens of times, especially if you have a hard data set. I think data scientists in the room have probably all experienced that before. So this entire process can take months, potentially dooming machine learning projects altogether as executive sponsors lose interest. So in order to help you overcome these challenges, we decided to build AutoML Tables, a tool for enabling your entire team, whether you're a data scientist, an analyst, or a developer, to automatically build and deploy state-of-the-art machine learning models on structured data. And I'm excited to announce that AutoML Tables is entering into public beta as of this morning. Thank you. And the way the product works is we provide a graphical codeless interface for guiding users through the entire end-to-end machine learning lifecycle, with significant automation as well as guardrails built in at each individual step, which I will show you shortly inside a demo. So we start with helping you ingest your data and then easily define your data schema and target, analyze your input features, in a feature statistics dashboard, automatically train your model, including automated feature engineering, model selection, and hyperparameter tuning, as well as evaluate your model behavior before deploying into production, and then deploying in a single click. Through this, we can help ensure that what used to take months of time only takes weeks or even days. Digging deeper into some of these different steps. So on the data ingestion side, we seek to handle data as found in the wild. So we provide automated feature engineering for essentially the major data primitives that you can find in BigQuery, things like numbers, timestamps, classes, lists, strings, and nested fields. We do know there are more other data primitives out there that we could cover, but this is our starting point. And we also worked hard to ensure that we're resilient to and provide guardrails for imbalanced data, missing values, highly correlated features, high cardinality features, like if every row had a different ID, and outliers as well. After that, we automatically search through Google's entire model zoo to find the best model for you, including linear logistic regression for the smaller, simpler data sets, as well as things like deep neural nets, ensembles, as well as architecture search methods if you have a larger, more complicated data set. And one of the benefits of being at Google is we sit next to some of the best research and consumer product teams in the world. So we can basically watch whatever great research results come out and take the best and put it into AutoML tables for you, kind of cherry picking the best for you. Sometimes even before results are published on them in research papers, so hot off the press. An example of this is our collaboration with the Google Brain team. So they delivered what they call neural and tree architecture search. So essentially what this is they took their architecture search capability, similar to the one that they use for image classification and translation problems, and they added tree-based architectures to the existing neural net architecture search space, and then also added automated feature engineering so that it can work for a wide variety of structured data. Note that this isn't published in research papers yet, so I can't give more details, but expect more to be announced soon. And based on the benchmarks we've done, the results speak for themselves. So there are a large number of vendors in this space, and we chose to benchmark against a subset of them with similar functionality. And we benchmarked on Kaggle competitions, which I love as a benchmark because they involve real data from real companies that are putting tens to hundreds of thousands of dollars of prize money on the line to find a good solution. And they're willing to wait months to get a good answer. That's typically how long these competitions take. And thousands of data scientists across the world compete in them. So these are, if you do well on a Kaggle competition in terms of the ranking, you're pretty much guaranteed that you're doing state-of-the-art work on a problem that matters for the world. So that's why we love this class of benchmarks. And here you have on the x-axis different data sets different Kaggle challenges that we benchmarked on. And on the y-axis is the percent ranking on essentially the final Kaggle leaderboard, if we had actually participated. So these challenges had already ended by the time we participated. We were just benchmarking on the final leaderboard after the fact. And what you'll see is that most of the time, AutoML Tables gets into the top 25%, which tends to be better than the existing vendors we tested. But caveats apply. Of course, for some of these data sets, we were in the middle of the pack, and we'll be the first to admit that we have a lot of additional work to do, and we're constantly tuning and improving our systems. But when it comes down to it, in general, we do pretty well. So benchmark results are here. And I wanted to dig into one of these benchmarks to give you a better sense of what it means to get into the top 25%. So here's an example called the Mercari Price Suggestion Challenge. Mercari is Japan's biggest community-powered shopping app and marketplace. And they created this challenge for predicting the price of a product offered on their marketplace so that they could give pricing suggestions to their sellers. So this is a real version of the example problem that I brought up at the beginning of this talk. So some logistics. This challenge went on for about 3 months. There was a $100,000 prize. 2,000 data scientists competed. And actually, the winning data scientist made about 99 entries in order to win this competition. So it was highly contested. It's not just like a pass-through easy challenge, right? And the data look kind of like this. So about 1.5 million rows of offer examples like this with some rich input features, right? So you've got the name, there are categorical values, lists of categories, item descriptions, and some of these are really, like this is dirty data, right? So you've got no description yet. What is the model supposed to do with that? You've got things like redacted values over here, right? And there were missing values as well. This is a good real life data set. And the goal is to predict the price on this column. Now here what you see is a curve where we laid out the performance of each participant in terms of the final error achieved. So the further you are to the right, the better that participant did on the final leaderboard, right? And the higher you are on the y-axis, the higher the error on the final test set. So as expected, there is a line that slopes downwards to the bottom right. But importantly, it isn't a consistent curve. So what you'll see here is that in the beginning, there's a steep decline, right? Where better feature engineering, better model selection, and all that, like it really matters. There's still more signal to be squeezed out of the data. But then there's a long plateau where basically most of the competitors have kind of done whatever they can to squeeze the signal out of the data already. So getting to the top 25% actually gets you to that plateau, right? And here is how AutoML Tables does after different numbers of hours of training. So the way Tables works is you select the number of hours. And here we have tables after 1 hour of training, 12 hours of training, and 24 hours of training. So caveats, right? The architecture search, the hyperparameter tuning process, these are all random. So if you run this yourself, it might be a little bit more, a little bit less. And we did do some limited data cleaning. So for example, previously the categories were split by slashes. So our system just treated it as one big token. So in order to treat it as individual words, you actually have to break out the slashes by replacing them with white space. But this is basic, very basic stuff, right? And of course, this is just the Mercari challenge. Other challenges might have different results. But still, for a million row data set, a million plus row data set with significant complexity, 1 hour of training by AutoML Tables gets you here. 1 hour of training. And oh, by the way, as I mentioned earlier, the competition prize for this was $100,000. And in comparison, 1 hour of training on AutoML Tables is going to be $19. And by the way, you click one more time. Well, so the winning model, and this is well known for Kaggle competitions, the winning model typically takes months of time to deploy, to actually productionize and deploy. But for AutoML Tables, with one more click, and you can deploy the model into production. So how does that sound? Is it a good deal? This brings me to my final point, which is by using AutoML Tables, you'll save money. Not only does it increase your team's efficiency, but also there is no large annual licensing fee. You basically pay for what you use. And how we calculate what you use is that it's just a small margin over the cost of the underlying compute and memory infrastructure used. So for example, when I said earlier that training costed $19 per hour, that basically represents the cost of 92 4-CPU machines on Google Compute Engine. We're using the equivalent of that, essentially, under the hood. And prediction and model deployment would be even cheaper than that. And regarding reference customers, we're thankful that we've had a significant group of customers that agreed to join our alpha pilot, with a number of them agreeing to be public references listed here. We're proud that we've been able to prove our relevance across geographies, industries, and company sizes. And you can see there are a wide variety of company types here and profiles here, with wide varieties of also sophistication in terms of data science. So you'll hear specific use cases from Fox Sports, as well as GNP Seguros shortly. But before we get too carried away, I'll be the first to admit that we are not perfect for everyone. So AutoML Tables is usually the best fit if you meet the following criteria. So first of all, you have to know how to create good training data. And this is probably the most important point, right? Somebody in the room needs to know how to take a business problem and translate it into an ML setup, or classification or regression problem of some sort, right? Binary or multi-class classification. And that person needs to be able to take training data, especially defining the label column, the target column, so that it represents the way you want the model to perform in production. And somebody also needs to understand how to make sure that the input features are the same, in terms of the distribution, are the same as what is available at serving time, so that you can prevent training serving skew. And a trivial example of this, if the training data was all in English, but then at serving time you were feeding Japanese to the model, obviously it would fail. Second, you need to be willing to wait at least an hour. So that's our minimum unit of training, is 1 hour. And if you're looking to do minute-by-minute iteration on your model, potentially so you can move quickly, maybe it's very early in your development phase, then you're probably best off using something else, like BigQuery machine learning or cloud machine learning engine. And finally, for now, I want to call out specifically for now, if you have a larger and more complicated data set, that would be ideal. So right now, if your data set is less than 100,000 rows, you won't be fully taking advantage of the advanced algorithms that we're using. And we're actively working on this problem and expect more announcements soon. But for now, the bigger your data set, the better. And the flip side of that is our current limit is set at 100 million rows, just to be conservative. But if you have a data set that goes beyond that, actually we're using Google's machine learning infrastructure under the hood. So we're built for much bigger than that. And we would love to talk to you if you have a data set like that. So please reach out to your Google account manager. And now I will go over a demo. One sec, let me load this up on my computer. Ready? Can we do the demo? Great. So now I'll walk you through the workflow using AutoML Tables. You start by ingesting that table of data that represents your problem, right? So it can be from BigQuery or from Google Cloud Storage. So you just select it from Google Cloud Storage, you select your table, let's say you want to use this one, and then you ingest. We've already ingested it to save everybody time. So the next step is after you ingest, you will see a schema page like this, where you can fix the variable type if it's set to be the wrong one. We do automatic schema inference, but you can update it if it needs to be updated, right? You can also change the columns in case they could potentially be missing, right? So maybe at prediction time, one of these columns might be missing, so you can turn on that it can be nullable. And then you select the target column. So for example, in this problem, actually the target column, the target is supposed to be deposit. So this specific data set is about binary classification, predicting after marketing outreach whether somebody will make a deposit at this bank or not. So it's a classification problem, and the target is deposit. And if you're an advanced user, there are additional parameters you can set. So for example, you could set your own data split between training, evaluation, and holdout sets. If certain rows are more important than others, you can set a weight column. And if this data has a ordering over time that matters, then you can set a time column, and this will make sure that the latest data shows up in the holdout set instead of the training data, instead of the training split. Next, after you've set your schema, we provide a dashboard of basic feature statistics so that you can detect common data issues. So, for example, we allow filtering by the feature type, and there are more options available, but this particular data set just has numeric and categorical values to keep it simple. And you can potentially see, okay, what % of them were missing. Maybe that could indicate system problems. You can see how many distinct values there are. So for categorical values especially, if you have a cardinality, the number of distinct values that is similar to the number of rows, then that probably means that that column adds more noise than signal, and you should remove it. And then finally, you can detect basic issues like correlation with target for target leakage, as well as for numeric feature types, seeing the basic distribution. And also, if you deep dive on any of these particular feature columns, you can see things like the distribution of the values, the top correlated features to it, and so forth. We'll keep on adding more as you ask for them. More feature statistic displays. Next, after you're comfortable with your data, you can train a model. So you set your model name, You set how many hours you want to train for. And usually, as you saw from the Mercari example, 1 hour is a good place to start. You select which feature columns you want to use. We automatically set an optimization objective for you, but if you want to set an objective yourself, because you know that one of them lines up better with your business goal, you can do that, right? And then you train a model. I've already trained a couple here, so let's deep dive into one of them. Next is the evaluation tab. So we provide both the overall performance of that model here on the top, as well as some useful metadata like what features were used and what it was set to optimize for, as well as allowing you to export the predictions on the test set to BigQuery if you want to do additional analysis, as well as evaluation metrics on individual label slices. So here, for this data set, the value 1 means that they did not make a deposit at the bank, and that's 90% of the data, right? So you'll see that you'll be able to see that here's the model performance for that slice of the data. And then 2 means that they did make a deposit, so that's the minority class, and you'll see that it does slightly worse. But that's typically common for imbalanced data sets, and it's up to you to figure out how you want to, whether that's sufficient or whether you want to try other things like improving the weight of the imbalanced class and so forth. So you can flip between them and kind of see the difference, right? You can set the score threshold to see how the precision and recall are at different points on that curve. If you're interested in exactly how misclassification is happening on the model, then you can look at the confusion matrix to see that. And then we have feature importance, just to give you a sense of which features were the most important for making those predictions. And finally, in the Predict tab, we allow batch prediction and online prediction. So with batch prediction, you can upload a table from BigQuery or from Google Cloud Storage and export your results there as well. And for online prediction, it's, like I said, it's one click to deploy your model. We deploy globally to make sure that you can get low latency serving. And then you can test your model here inside the dashboard. So hopefully the demo gods are kind to me and this is working. Great. So you can see the prediction result, right? And for regression problems, we would give you a prediction interval, a 95% confidence interval. And for classification, we would provide confidence scores for the different labels. And that concludes my demo. Can we move back to the slides? Great. And now I'm excited to introduce Chris and Jack to share how Fox Sports is creatively using AutoML Tables to deliver a brilliant audience experience. So, all right, and clicker.
So, g'day. My name's Chris Pocock, and first of all, I'd like to say thank you to Tin Young and the team at Google for inviting us over from the other side of the world to come and share our story about Monty. I'd also like to introduce Jack Smythe, waving over there. He'll be talking to you again in a few minutes' time. So look, I look after marketing for Fox Sports Australia, and it's kind of a privilege to be able to get paid to talk about sport all day long. So it's a pretty cool job. So I'm actually originally from the UK. I've lived in Australia for about 5 years. So I want to start off by giving a foreigner's context on what sport means to Australians. It's a sporting nation. It's kind of the little guys punching above their weight. It's not just part of the life. They live and breathe it. It's part of the psyche. It's part of their national identity. They identify themselves through sporting success. So sport is a really, really big deal in this country. To give you a little bit of context, looking at the greater Los Angeles area, there's 18 million people that live there. They've got about 10 professional sports teams by my reckoning. Sydney, 4.5 million people, pretty big. We have 25 professional sports teams. So there's a lot of sport to go around. The other kind of contextual thing is that Australians have kind of looked at international sport, and they've looked at football, soccer from Europe, and then they've looked at American football and gone, nah, it's not for us. We're just going to invent our own sport. So they've invented Australian rules football. It is probably one of the most popular games in the country. Only played in Australia professionally, but it is a big, big sport for them. So big that in this little country of about 25 million people, they pack out a stadium, 90,000 people, week in, week out. So it's pretty impressive. But Australian rules football is not the only sport played. Australia is actually a pretty divided nation when it comes to sport. So I'm just kind of highlighting up some of our key sports we have here. So we have rugby union at the top, Australian rules football, rugby league, and motorsport. Those are the key broadcast sports that we have on Fox Sports. But within Australia itself, certain sports have bigger popularity than the other, depending on where you live or where you went to school. Rugby league, for example, really big in Sydney, not so much in Melbourne. Australian rules football, really big in Melbourne, not so big in Sydney. So it's a divided nation. So it kind of takes us through our journey at Fox Sports, where we have all these key sports from January through to September. It's a great lineup. There's a bit of a gap in the summer. So last year, we signed a broadcast rights deal for cricket. And cricket is the summer sport. You'll notice that it kind of looks at October, December. We're upside down. That is our summertime. So that kind of filled the gap. And cricket, it cost us $1 billion for the broadcast rights for that. So there's a little bit of importance on making it work. So we had to look at cricket from a context of it having been on free-to-air television. So Australians have been able to watch it for free since day dawn. We're now asking you to pay for it. So we had to promise a cricket experience like never before. And this is kind of where our AutoML tables came in. Now, I'm conscious of where I'm standing and what country I'm in, so I just want to talk a little bit about what cricket actually is. It's a game that we sometimes play for 5 days and no one wins. So I kind of think that blows a few minds in Australia. We draw quite a lot. But it can be like a chess match. It's really, really tactical. And what you'll see is kind of the last man holding on against big Goliath fast bowlers, or the game changing on a dime with 3 quick wickets. It does explode into action, but realistically, there are only 18 seconds of wicket, so the wicket being this guy here. The aim of the game is for this guy to bowl this guy out. That really gives us, across 5 days, 18 seconds of action. It's a long, long game. So what we try and do with this experiment with the AutoML tables is to warn fans when we think a wicket is going to happen ahead of time. So they know that they need to be in front of the screen, don't go to the bathroom, don't go out and do a barbecue because the action is coming up. Now, cricket also is a really great game for structured data. There's a lot of different variables that we can measure to accurately predict what we think is going to happen in the future. The types of ball bowled, you can do spin, you can do fast. How long has the batsman there been at the crease? Has he been there for an hour? Has he been there for 4 hours? Is he tired, not tired? Has he run around a lot? Is he the last man standing? Generally, the last man standing is a lesser batsman versus the first guy who goes out. What field positions has the captain set out around? Where they're looking to catch the ball? And about 80 other data points. So it makes it an ideal experiment that we tried out last summer. And it bloody worked, which was quite impressive. So look, I want to let Monty, so just a little bit of context, we named him Monty because the first wicket he accurately predicted was a chap called Monty Panesar, so it seemed apt to name him after that. So I'm going to introduce you to, this is a world first, our world's first automated machine learning commentator. I'll let Monty give it to you in his own words.
Yes, yes! Close, Byron given immediately. Oh, what a catch! She said that he's taken the catch.
right, thanks so much, Chris. Hi, everyone. My name's Jack. Oh, I'll wait for applause. My name's Jack, and I'll walk you through how Mindshare created Monty in collaboration with Google. Now, the first step was to find a world-class data provider in Opta Sports. So they track 83 unique variables with every single ball, and that's available within seconds of it leaving the bowler's hand. So we knew we had great training data and a live feed set up. So after that, we could start experimenting with tables. Now, I'll say the first impressions of tables was striking. The speed and simplicity of this platform blew us away. We could easily ingest a year's worth of training data, simply select wickets as the label to predict, and within hours, we were seeing impressive results. To be totally honest, some of the team members even thought that Monty must be cheating because the early results were simply that good. However, those doubts quickly evaporated as we moved through the training process. Tables allowed us to collaborate a model that could keep pace with a live game. So we moved ahead with a classification model so we could not only predict when a wicket would fall, but how. And the final output looked something like this. This is a real example from a recent game between England and the West Indies. And you can see the endpoint would return an analysis of the latest ball. And in this case, the batsman's safe for the next 5 minutes. The prediction is not out. But then you can see the confidence scores for each method of taking a wicket. And there's a rising danger there of him being caught. So once we saw the accuracy during testing, we knew that Monty was ready for the main stage. And I have to say, as Australians, we don't really believe in soft launches. So we chose the biggest, most iconic match in the Australian sporting calendar to debut Monty. Now, millions of fans...
The MCG. We come here every Boxing Day for Australia's biggest day of cricket. Day one of the Melbourne Test match. More than 80,000 fans in the stands. Millions watching and listening around the world. Magically drawn to the history and the tradition. This is where reputations are made.
Got him. Let McGrath, there's 300.
This is where Dennis Lilly knocks over Viv Richards with the last ball of the day.
He's got him. Well, what a magnificent start for Australia.
You don't forget that. As a kid, you dream of doing something amazing at the G, and a few get lucky.
All right, so how did he go? Monty absolutely... You can go to the next slide. That was seamless. So, how did he go? Monty absolutely smashed expectations in his first game. We were thrilled with the accuracy. And tables really came through when it counted most, when we have most of the country counting on Monty's call. So his confidence scores for each wicket were displayed live in ads just like this for millions of fans. And that stretched from push notifications in the Fox Cricket app all the way through to pre-roll. And we were thrilled with that accuracy figure. That is astonishing for live sport. And I would say as well that even the moments he missed became highlights in their own right. Because that meant that a bowler had come out of nowhere to take a wicket without warning and had literally beaten the odds. Now, as our confidence grew in Monty, we essentially scaled him up to become the command center of our entire campaign. So this is the final architecture, and this is largely thanks to an amazing Googler back in Sydney named Drew Jarrett. And in the time remaining, I'll give you a quick overview of how it worked. Down here, when a ball was passed to our system from Opta, App Engine would receive that, it would pass it through for processing, we'd use Dataflow to look at that ball, and also an aggregate of the recent balls to give us what we called a prediction window. The model would then make a prediction based on that window and the individual ball, and then App Engine would facilitate requests from live digital billboards, from the Fox Cricket app, Google Ads bidding scripts, Studio Dynamic templates, and even Google Assistant. And I have to say, for me, the Google Assistant experience was a particular highlight. This was combining the predictive power of AutoML Tables with the personalization capabilities of Assistant. And we could genuinely offer every fan their very own on-demand commentator. So through Assistant, fans could ask for the latest call from Monty, they could understand how he had made that prediction, and of course, they get the latest team news. And for me, this is more than marketing. This is an entirely new product experience made possible through Tables. And it's one that we are very, very proud of. At the close of the campaign, the impact of Tables was clear. So we saw a 150% improvement in marketing ROI, brand recall for Fox Sports doubled, And the Fox Cricket app delivered an increase of 140% compared to category competitors. So with a scorecard like that, you can be certain you haven't heard the last of Monty, and I'll hand you back to Chris. He'll be able to talk you through where we're going next.
Thanks, Jack. So those are pretty damn good results. And it frankly took me by surprise just how well it all worked. So this is not the end of our journey. What we really want to do is take Monty forward and beyond what we've done this last summer. Not only taking it into our next summer, but also start applying it to some of our winter sports. So we're looking at doing a man versus machine. Let Monty take on our sort of panel of experts. What do they think the results are going to be? Can they beat AutoML? Really excited to see if they can or can't. We also want to be able to integrate it properly on our air, so on our broadcast, being able to allow our commentators to warn fans when exciting moments are upcoming. Don't go to the bathroom. Make sure you stick around. Monty thinks there's a wicket coming. Fantasy is also a fantastic way of applying Monty's learning model. Each week, he'll build his ultimate team, and can it beat all of our consumers, all of our experts, week in, week out, by building based on structured data versus the gut feel of our experts. Let's see what happens. I'm really excited for the future. It's been an amazing product, a great journey. So thank you to everyone, and appreciate you listening to our story.
That was awesome.
So now just my last role of the day is to introduce Enrique and Carlos from GNP Seguros. Hopefully I pronounced that properly. But welcome, guys, and thank you.
Thank you very much. Well, hello. Thank you to Ting Yon and to Google for inviting us to share our experience with AutoML at this conference, and congratulations to Fox for such an interesting case. GNP is one of the largest insurance companies in Mexico. The company was founded 116 years ago, and we have yearly sales of around $3 billion. As any large and well-established company, GNP is undergoing a profound transformation. I was going to say a digital transformation, where we haven't quite figured out the precise definition of digital transformation because everyone's talking about it, so I'll just mention transformation. But anyway, what we want to do is to modernize our information systems and our operations, and we're leveraging heavily on the cloud to achieve that. And one of the strategic initiatives that we're executing under this transformation is to assemble a single corporate data lake. That is a single repository where all the information of the company will reside. And besides being an important enabler of efficiency, because we don't have to figure out where to go and look for information because everything is going to be located or is located already in the central data lake, we regard the data lake as an important source of competitive differentiation and of intelligence. And to achieve that, we need to squeeze knowledge and value from all the data that's stored in the data lake. And to achieve that, we have recently started to use machine learning to actually, uncover and squeeze the value from the information. And the problem with machine learning is that the availability of well-trained data scientists is not that great. So Carlos is the head of machine learning at GNP, but he's kind of a rare breed of persons because you don't have that many in the market. So when Google offered us described to us the concept of AutoML Tables, and they offered us the opportunity to test it, we thought it was absolutely great because we want to democratize the use of machine learning in the company, lower the complexity of generating new models. So it looked very promising, and we embarked on testing and trying this this great new tool. So what we did is we played with the tool with 3 different use cases. One in the auto industry, in the auto insurance line of business. One in the healthcare line of business, and the third was general utility for our underwriters for collective insurances that we'll describe a little later. So the first example it's really simple. It's given the characteristics of the insured car and of the owner, try to predict what's the probability of that car of having an accident. And to provide the highlights of this, the technical highlights of this exercise, I'll allow Carlos to share it with you.
Okay, hello to everyone. I will only explain how are we using AutoML tables to solve insurance problems at GNP. As Enrique said, the first problem is car claim risk. This problem consists in determining and predicting the probability of a car accident using drivers' characteristics such as age, gender, claim history, as well as vehicle characteristics such as type, model, and intensity usage. One thing that is real amazing about AutoML tables is that you don't have to worry about feature engineering or hyperparameter tuning, development issues. The only thing that you need to do is the one that made Tinjun at the demo. And I want to highlight that this had a very good quality compared by the F-score in the green square. And I will let the next problem that Enrique introduced.
So the second use case that we used to try AutoML tables is we had previously already developed a machine learning model to try to detect fraudulent claims in healthcare. And what we did is, we created a new model using AutoML tables, and we compare the results to the results that are already provided by the existing model that we have. And given the characteristics of, of the patient, which is our customer, and the sales agent who sold the policy to this customer, and the specific disease that this person has, and the hospital and the doctors involved, we try to determine if that claim is fraudulent or not. Just to give you an idea, our yearly expense on healthcare claims is around $680 million. So any small percentage that we can achieve in improving the, detecting fraudulent claims, it translates directly into a lot of additional revenue to the company. So I let Carlos, provide you with the highlights of this exercise.
Okay, thanks, Enrique. Again, we use the client's claim history as well as medical and hospital's information. And one thing that is really neat about the AutoML tables is that you have all the performance evaluations or the performance results that you need at a click distance. You don't have to make additional work in order to compute evaluation matrix. And I want to highlight that this model had a very high quality compared by the F1 score of 0.94, and we confirmed this quality on an independent holdout set, and I want to highlight that it got 20 to 30% improvement with respect to our existing ML solutions.
So bottom line, what we were really impressed is that just by using AutoML, we got a 20%, between 20 and 30% increase in effectiveness of detecting claims. So that was really promising and very encouraging to continue using this tool. And the last example was a practical example. We not only insure individuals, we also insure collectives of people. That is, for example, all the employees of a company. So let's say that we're going to insure all the employees of a specific company. So what usually the sales channel does is once that they do the sale, they provide either a CSV or a spreadsheet file to our underwriting department so that they can do the quote and the underwriting of the policy. And one of the fields that is required for each of the persons that integrate, this collective of people is the gender of the person. But sometimes, the sales channel omits to provide that information. And when that happens, the underwriting department, they need, what they usually did before was break up the file into, many small different files and then send that file to a lot of different persons, and manually each person will basically classify based on the name of the person, if that person is male or female. So, the last time that happened, one of the last times that happened, the file was 10,000 rows long. So it was a lot of work. So, one of the persons from the underwriting department approached our data science team and said, well, you're supposed to be smart, and there should be a better way of doing this. And it was a simple example. What we did is basically we used our master database as a source. We use the data of the master database to train a model to learn what's the gender of a person based on its name and last name, so its full name. So that's basically what we did, and that was it's a small problem to solve, but it's actually it had a lot of practical usage in the company because this kind of happens kind of often. So it ended up being a usable tool, and I'll let Carlos describe just this exercise.
Okay, thanks again. Well, as you can see on the screen, we made a comparison between a naive model only using the feature column of the first name, and obviously it got a bad quality result. And we made a little character level feature engineering, and we decomposed the first name into suffixes and prefixes, and we gained a lot of performance, as can be seen on the screen. This shows the power at hand that makes AutoML tables when the relevant variables are chosen. Again, I want to thank the Google Cloud team for letting shape the cloud together.
Yeah, so in this example, by tweaking a little bit the feature engineering, we were able to on leveraging on AutoML tables, we were able to achieve a very high efficiency of this model. So this is just another small example of how can we use this tool. And the results that we saw in AutoML, with the use cases that we develop at GNP, are really promising. So we're really excited in the idea of leveraging on this tool to developing more machine learning models much more quickly. We're determined to use machine learning to solve real business problems or problems that are already solved with some sort of automation, giving them a much better solution. And one way to achieve these results quicker is through tools like machine learning. And one of the things that we want to achieve is currently the underwriting of medical healthcare goes through a process and using a set of predefined rules. Around 55% of all the new customers, its underwriting process is fully automatic. And we want to change the implementation that we have. We want to replace the static rules with a machine learning model that would allow us to have 80% of all the underwriting instances to be fully automatic, and only at 20% will be derived to a set of experts to determine the underwriting. So that's one of the targets that we have. And on the other end, since we already compare the results that we got with AutoML with the existing machine learning model we have for detecting fraudulent healthcare claims, we want to improve in 10% this year the amount of fraudulent claims that we're able to detect in order to contribute to additional revenue in the company. So that's basically what we've done at GNP. I think this is a great tool. And back to you, Tinjun. Thanks.